Hi Math 95. In the second part for our Completing the Square video, we're going to finish working on this worksheet together. I first wanted to mention a little something here in example 4. I'm not going to do this one with you, but I will give you a suggestion on how to start. So it says the hint is to simplify first. And the suggestion here really means that you have to work out this sort of grouping that's over here on the right side of this equation here, because notice that we have to gather all the variables over onto one side because we want to have the constant term separated by itself on the right side. Okay, so my suggestion here is to first apply that distributive property to that 24 by applying it to both terms, and then scoot that 24a over to the other side, and then complete the square on this equation that you have right here. Okay. And I'll let you work that one yourselves, but I want to move to example 5 because this one's a little bit trickier because, well, quite honestly, it has to do with the fact that the middle term right here, the number that lives in front of the x, the thing we're going to work with when we complete the square, isn't a number that's divisible by 2, which means we're going to have to work with fractions. Okay, so let's, and I know how much you guys love that. So example 5. Here. So let's start out with, we have the equation x squared plus 5x plus 1/4. Now, first of all, don't we already know we want to move that over because we have to get the constant term all by itself, okay? So let's just move that over right now. So if I subtract 1/4 from both sides, that puts that guy right over there, okay? So let's see, now I have the space all ready for that number that I've just put right there, okay? So that means I have to pay attention to this number that lives in front of the x, this guy right here, the plus 5. I have to take 5, divide it by 2, and square it. Remember, that's always what we do. We take the middle number, this number right here, divide it by 2, and then square it. And that's the number that's going to go right up here, right in this little space right here, as well as over here to balance the equation. Okay, 5 over 2 isn't anything nice, and let's not go to decimals, but I do know that that's 25 over 4, right, if I apply the exponent to both pieces, numerator and denominator. So let's just work with the fractions, 25 over 4 right here, and we've got, that's a plus, by the way, we have to add that, plus 25 over 4, and do the same thing over here, plus 25 over 4. Okay, so now let's see what we have when we try factoring the trinomial that's here on the left side, because remember that's our next step, is factoring the trinomial. Okay, I write this as, what's it going to factor into? Let's see, x, and I'm going to have something squared. What am I going to, let's see, it's same sign, both positive, so I know it's a plus here. And here's the hint. The number that goes here is always what's right in here before you square it, right? So that is always what goes right here, okay? It's always the middle number divided by 2 that goes right here next to that x inside of the squaring action, okay? It's just a little hint. Okay, on the right side, what do we have? Negative a fourth plus 25 fourths is 24 fourths, and we know that as a nice number, so we'll simplify that in a second. This, by the way, is again a candidate for the square root property, so let's go ahead and apply that. Okay. So because I have something squared equals a number, and this is the number 6 right here, so we'll be able to rewrite that as the number 6 in just a second. I can write this as x plus 5 over 2 equals, let's see, it would be the square root of 6, or we could have x plus 5 halves equals negative square root of 6. Okay? Because again, that's just applying the square root property. It says something squared equals a number, so that something is the square root of the number or the negative square root of the number. Again, we can compress this into a single notation to write this as x plus 5 halves equals plus or minus square root of 6, and square root of 6 is done because it doesn't have any perfect square factors in it. So now just solve for x. We subtract 5 halves from both sides, and that 5 halves doesn't work with inside the radical, right? It has to just live out front, okay? But we're going to add it and subtract it to this radical right here. So I have, when I subtract 5 halves from both sides, I get negative 5 halves plus or minus the square root of 6. Okay, and that's our final answer for that one because it's nasty enough as it is, right? Okay, we don't want to mess with it anymore. But it does say you take this negative number and you add or subtract a square root, right? Okay, so remember this represents 2 answers, right? This is 2 solutions. Okay, excellent. Let's try moving on to our next one on our sheet. I will let you try number 6, but I want to work down here when we ask ourselves the question, what happens if the leading coefficient is not 1? Now remember what the leading coefficient means. That means the number that lives out front of the x squared, right? Okay, that's the leading coefficient. In all the ones I've done so far, the leading coefficient has been 1, right? So let's consider an example when it's not, okay? The key to doing these ones is to get the leading coefficient to be 1, right? So what we're going to do is if we see a number out front besides the number 1, we're going to divide the entire equation, both sides, by that number so that the leading coefficient turns into the number 1, okay? So let's work example 7, and this will be our last one because I'll let you do example 8. So I see we have 4x squared plus 16x minus 48 equals 0. Leading coefficient here is 4. So let's just do ourselves a favor and make that a nice number 1 right there by dividing everything by 4, right? This is nice because notice all of the coefficients are divisible by 4. So this is going to work out very nice, okay? So our equivalent equation when we divide everything by 4 is x squared plus, let's see, 16 over 4 is 4x minus 48 over 4 is 12 equals 0. Okay, and let's see. So how would we complete the square on this thing? We have to move the 12 over, right? So let's move the 12 to get the constant on the other side. Okay, x squared plus 4x space equals 12. And let's see, now we are ready to figure out what number needs to live there to make this trinomial on the left side a perfect square binomial. So what do? We look at this number right here. This is the b, if you remember, from ax squared plus bx plus c, right? So this is the b, right? What we want to do is take that b number, that 4 that lives right there, we want to divide it by 2 and then square it. Remember? And that's the number that goes right there. Okay, so let's see, 4 over 2 is 2. We square that, we get 4. So we're going to put a plus 4 right here, but what we do to one side of the equation, we must do to the other. Good. So now, let's write it in its factored form for the left side. This trinomial right here is a perfect square of x plus 2 squared. Again, how did I know that? Because remember, secretly I know that the thing in here before you square it is the number that goes right there. Okay, a little trick, a little shortcut. Okay, and this is going to equal 16 because again, remember, we didn't forget to add 4 to the other side as well. Again, square root property. And so let's see, we write this as x plus 2 could equal what? Plus or minus square root of 16, because now we're thinking about, again, the fact that we could have that or statement, right? It could be x plus 2 equals the square root of 16 or x plus 2 equals negative square root of 16. And since that simplifies nicely, that's x plus 2 equals plus or minus 4. And so now we have to be really careful, okay? And this is why I wanted to write it like this, because it's really tempting to say, okay, subtract 2 on both sides, and write this as x equals plus or minus 2. That's really tempting, but it's not okay to just think about subtracting this 2 from that 4, right? Because remember, this right here, this plus or minus 4 actually says that we have 4 or we have negative 4. Okay, and when we subtract 2 from those numbers, they do different things, right? We don't get plus or minus 2 if we subtract 2 from each of those things like that, right? So we have to be really careful about how we think about using this plus minus notation, okay? So let's erase what we have right down here because I think this is pretty much nonsense down here, okay? Let's consider for a moment that we have these two possible answers over here, the 4 or negative 4, okay? And if we hadn't used this compressed notation, we would have had x plus 2 could equal 4 or x plus 2 could equal negative 4. And when we subtract 2 from each one of those things, what do we get? We get x could be 2, right? That's when we subtract 2 from this guy. Or we get x could be, when we subtract 2 from this guy, we get negative 6. Okay? So again, be really, really, really careful about using that plus minus notation right there because it can throw you for a loop when you have to say subtract 2, right? You can't just subtract 2 from that 4 and say you get plus or minus 2. That's not how that works. You have to think about the two individual numbers you get. Okay? All right, so I will let you try example number 8, and then if you have questions on it, of course, we'll talk about this next time. Be careful with this one on number 8 because you do need to divide everybody by 3, but notice that the b number, the one that lives in front of the x, he's not divisible by 3, so you're going to have to think about some fractions, okay? So be careful when you're working with those fractions. All right, enjoy the quadratic formula song that I also posted to Moodle, and I will post some answers for this worksheet also so that you can check those as you're working through.